lecture 3 of this real analysis UPSC mathematics optional. Hope you all enjoying the lectures, in which way I am trying to convey the real analysis. So actually yesterday only I was talking with my student Dinesh, so he told me about that. He said pure maths के लिए there is not a one-stop solution for us. So please try to elaborate these concepts like you are doing already. So yes, I'm committed, I'm determined to do so. So let's start our lecture 3. And lecture 3 is completely dedicated towards a beautiful concept. Denumerable. Some people say countable and uncountable sets. One thing I want to clear, although this concept may seem very obvious to you guys, but you people may think that why sir is focusing on this concept, because UPSC is not much focused on that. PYQ says कि UPSC has not asked some like direct questions over this topic. So dear, you are a student and I was aspirant, now a teacher. So I understand. I tried to observe what is the pattern of UPSC. What happens is, if you talk to your seniors, they will tell you that pattern is being changed. And as a teacher, what I observed is, we have to stick on the syllabus, but not sticking on the PYQs only. We have to think कि okay, if real analysis is mentioned in our syllabus, so yes, there is a possibility to have some question from this topic also. So always I suggest that don't leave any topic completely. Okay, if PYQs are being asked continuously, you can revise, you can practice that chapter, that particular point well, but that doesn't mean you will completely ignore some of the topics which are in the syllabus but not being asked frequently. So this is a beautiful concept. Again I will say, as the pattern of my teaching is, I try to open each aspect of a concept, because once you realize it, the life becomes easy. So for this topic, okay, in the starting only, today I am giving you a target, and the target is find a bisective. Bisective means 1 1 onto map. Map means function from open interval 0, 1 to closed interval 0, 1. So you have two possibilities, whether it is possible or not. Means you can find, and from here only I will start today's topic. How? If you are able to find a 1 1 onto map between this and this, I am saying if yes, then we may say that there is no difference between this and this. And difference doesn't mean element wise. Difference means these are some classes, you can say. Moreover, You will be surprised if I am giving you the next target as can we find a bisective map between this and this. So over the finite set, please focus on the word over the finite sets, we already studied 1 and 1 but now I am more interested in knowing about this. So let's start the chapter. This is target for you, okay? The next lecture, please let me know about this, whether this is possible or not. If possible, then come up with a formula like what is that f of x. And my chapter is being started from here only. So the thing I want to teach you today is, what do you mean by finite set, infinite sets? What is countability? Countability means, simple you can say, denumerable. What? Denumerable. If some people are from Hindi background, that is Gananiya, means you can count. If you can count, means you can tell what is the first element of that particular set, what is the nth element of that particular set, and so on. For example, if I say set of rational numbers, okay. For example, if I say set of integers, for example, if I say 2z, means set of even integers. So is this set countable? Means can you tell me what is the first element, what is the second element, and so on. Can I count elements in the set of rational numbers? You getting my point? One more question, please note it down. Does only finite sets are countable? Note it down. Are only finite sets countable? Question mark. Infinite sets are always, another question, always countable? Question mark. Infinite sets may give an example which is countable and which is not countable. You got my point? So that is the target 1 of the class, trying to know about countability. Okay bache, what we wish to have? Checking the countability of some given set. There are some beautiful concepts. Please don't afraid from the name. It is Cantor's. What Cantor's theorem says, if A is a set, then let's say PA is the power set of A. What is power set of A? Tell me. What is power set of A? Collection of all subsets of A is known as power sets of A. Okay. So what Cantor said, ki between A, please note it down roughly. Actually this is the way of teaching. First we try to figure out what is the target of the lecture, then only we will be able to learn something. Otherwise we will be always in the panic situation ki pata nahi what the next will be, what the next will be. So the thing is the consolidation. And believe me dear, from last 15 years I have been doing this maths, then only I am able to do such type of consolidation. And I want to deliver it for you all guys. So what Cantor said, ki between a set, suppose that you have a set A and power set of that set PA. So what Cantor said, ki between A and PA, there cannot be defined a bisective map. याद रखना ऐसे स्टेटमेंट को, अभी इस पूरे चैप्टर में we will be using it. Remember it. So one is cantors. Have you ever listened about these alaf numbers? Hebrew words. Alaf. One word we will be using here, cardinality. Cardinal numbers. So what does that mean? Cardinality of set of natural numbers and cardinality of z or cardinality of q is same. That is our question of the lecture. Interesting na? कि how q का cardinality can be same as n का cardinality. And one more interesting question is कि cardinality of n or q, cardinality of q and cardinality of r can be the same or not. Ready? So as I told you, Cantor's wala, from here I will come up with more beautiful examples, groups and subgroups here. Getting? So this is the beautiful concept for us. Now I will give you 4 to 5 points. The story is clear to you or not? Story mind में set हुआ कि why this chapter is very beautiful for us, because things we think that very obvious, but those are not so. Clear है अभी? Any issue? चल, let's move on. So number first is, as I told you, real analysis, you may feel that everything is obvious, but everything is has a proof there. So please note down. Now start. Acha, notes you are preparing or not? If you are not preparing class notes, means you are not a disciplined student. Okay. See, I am coming from the lake na. बारिश में भीगा हुआ है अभी. Still, I am determined कि I have to take the lecture. Means take the lecture. Okay. So you people please at least थोड़ा तो भाव देंगे करके. चल. So if I ask you what is finite set, and I will say, don't laugh please. So as my dear students all knows कि I always focus on the definitions, because once we are clear about the definitions, everything is gonna be easy. So what is finite set? Don't think I am telling you only finite set. I will create a sequence. I will create a flow. So what is set? A set, capital A, or you can say S, is said to be finite if there exists some finite n belongs to n such that f from S to n is a bisection, right, where n is just a subset of n containing n elements. So why I write such basic definitions? Because I have seen many people who are doing research, PhDs, they even don't focus on these things and they deliberately doing mistakes. So when I told you, when some given a statement or definition, when saying if there exists, means what is our target here? Please learn such techniques. You will feel very comfortable. What I say, if there exists such a finite n, such that this thing happens, means if there exists such n following these conditions, then we say A is finite. If there does not exist such n, we say A is not finite. Am I clear or not? Chal. For example, if let A is some A, B, C, D. So what I can say, A is a finite set. Why actually? Since there exists n equals to 4 such that f from A to N is a 1-1 onto map. 1-1 onto means bisection. Getting? Defined by, if I define f of A is equal to 1, f of B is equal to 2, f of C is equal to 3, f of D is equal to 4. And believe me dear, if you are in the habit of writing this, the things which seems very bigger becomes smaller. Because this habit needs to be developed in mathematics. Okay? Let's say if you want to say this is bisection. So people say showing 1-1 onto is a task. No. I told you in the group theory part. Showing this as 1-1 onto not a task. Finding such map is a task. Am I clear or not? So if not clear, then rewind the video. So finite set ka definition is okay? Any doubt? Okay. Now I'm gonna start countable. What is countable set? Other is countability, or you can say countable sets. So what is the first task? Definition. A set S is said to be countable. A set S is said to be countable, or the other word we use, denumerable, if there exists a bisection, So what is the target when you want to check some given set is countable or not? Means finding such map, finding such bisection. Once you are able to find such bisection, then that is said to be countable if there exists a bisection between A and set of natural numbers. So please इसको box में बंद, do it and do remember this definition. Now I am taking some examples and beautiful examples. See, if you start the counting, whoever started the counting, so he or she must have some base, like some reference should be there. So for counting, our reference is set of natural number. What dear? Set of natural numbers. Means to check the countability, we need to have the base as natural numbers. Means with the help of natural numbers, we will check the countability. Is that clear to you? So if someone asks that Z is countable. Fine. Acha, one more task I am giving you. As I told you the definition of finite set, in the next lecture you need to tell me what is the definition of infinite set. Will you? Chalo, pata nahi, you will do that. Let of manrega mazduri. I save your time. If there exists a bijection between a proper subset of that set and set itself, means suppose that 0,1 interval is the proper subset of R or not. So if you are able to find a bijection between 1 on to map between this interval 0,1 to R, then R is said to be infinite. You getting my point? So not over R, you can talk about like n LO and 2n. 2n means 2, 4, 6 and so on. So you can find a bijection between 2n and n. So if this thing happens, then you say that set is an infinite set. So please note this definition also. What I can say is, in the interview, if some person is from the mathematics background and you have mathematics optional, then you may have such obvious definitions, and believe me, you will be judged over that. Because mathematicians, they cannot ask us to solve you questions. They'll ask some general terms. Even I am not from the mathematics background, still I am interested to know what is finite set, what is infinite set. Clear? चलो आपको बता ही दिया. Come on this picture. Z is countable or not? So what is the definition, बच्चे? A set S is said to be countable if there exists a 1, 1 on 2 map between that set and set of natural numbers. So what I will do, पहले तो अपन we will do the मनरेगा मजदूरी method, okay? Then there may be n number of ways to get such bijection. For UPSC, that is more than enough. For persons who are preparing for others, क्योंकि कुछ TIFR वाले बच्चे भी like design and all भी रहते हैं, so for them I will say, please take this as a basis question for you guys. They ask questions over this in the different kind of stuff, but base or theme remains same. Please mark star over here. Okay, so be it UPSC, be it TIFR, be it IIT, be it any exam, I say any exam, interviews or written, you may face such basis. So to check Z is countable or not, what I do, अच्छा बच्चे बताओ, n is what? 0, sorry, I'm sorry, 1, 2, 3, 4 and so on. Z is what? Negative integers, 0, positive integers and so on. Now what I do is, let's say I map 0 to the element 1. Mark star over here. A very beautiful concept. What I do is, I just take a map F such that Z to F कहाँ से बच्चे? Z to N. So just to make you visualize, what I did is, I have written Z here. Suppose that I map 0 element of Z to 1 element of N. Suppose that this 1 I mapped to 2 of natural number. Suppose that this 2 I mapped to 4. Suppose that this 4 or 3 I mapped to 6 and so on. 1 1 जा रहा है कि नहीं? Is it 1 1 or not? Yes. Now what next I do is I map this -1 to 3. 3 of what? Set of natural numbers. Is that clear? Fine. -2 I mapped to 5. -3 I mapped to 7 and so on. So this is the set of natural number and very beautiful picture in front of us, mapping from Z to M. What I did, 0 is mapped to 1, positive integers mapped to even natural numbers, negative integers mapped to odd natural numbers starting from 3, because 1 I have already mapped here. Now check it out. This F is 1 1 and onto or not? 1 1, yes, because no two elements will have the same image